Wait, sir. I will give the introduction about.
Okay, madam.
Wait for a minute, sir. Welcome you all for the once again. I welcome you for session 5. It's my immense pleasure to introduce today's resource person, Dr.G.Prabhakar sir, Professor, VSB Engineering College, Karur. Welcome you, sir.
Well, thank you, madam.
Dr. G. Prabhakar is currently working as an associate professor in the Department of Electrical and Electronics Engineering, VSB Engineering College, Karur. He obtained his BE degree from Arulmigu Kalasalingam College of Engineering, Krishnankoil, under Anna University in the year of 2009, and M.Tech degree in the specialization of Embedded System from Hindustan University, Chennai, in the year of 2011. Then he started his career as a DSP design engineer in Vensal Technologies Private Limited, Chennai. There he carried out Icon Tech Korean client projects in the domain of H 2.64 high definition standard video streaming for network IP camera, and involved in the design and development of PCM based face recognition algorithm. He obtained his PhD degree in the year of 2018 under the Faculty of Electrical Engineering, Anna University, Chennai. His area of interest are embedded systems, cyber physical systems, robotics and control, nonlinear control systems, mechatronics, and image and signal processing. He has published more than 25 research articles around the world, including reputed journal transactions like IET, Springer, Taylor and Francis, and Elsevier. He filed and published 5 patents in the field of electrical engineering. He has written and published 5 books under reputed publications. He has 10 years of experience in teaching and research. He acted as a referee in Science and Engineering Research Board, Department of Science and Technology, and also reviewed 2 proposals. He acted as a resource person for AICT-sponsored FDP and STTP programs organized by various engineering institutions. He acted as a guest editor for the special thematic issue, Emergence of Electrical and Electronic Systems and Health Industry, under the Journal of Current Signal Transduction Therapy, Phantom Science Publications, in the year of 2019. He is one of the editorial board member in Journal of Marine Science, bilingual publishing owned by Nanyang Technology University, Singapore. He is an outstanding reviewer in IEEE transaction on mechatronics, and IEEE transaction on control system technology, IEEE transaction on intelligent transportation system, IET control theory and applications, and IET Collaborative Intelligent Manufacturing, ICE Transactions, and Elsevier journals. His Google Scholar H-index is 7 and I-10 index is 4. Recently, he has received Dr. APJ Abdul Kalam Award 2020 for innovative research from the Society for Engineering Education Enrichment. He is also a member in international societies like IEEE CSS, ISTE, and IETE. Now we invite Dr. G. Prabhakar sir to share his research ideas in the field of sensor fusion in robotics.
Thank you, madam. Thank you for your nice introduction, madam.
Thank you, sir.
Can I share my PPT, madam?
Yes, sir.
Sir, my option is not enabled. For sharing, my option is not enabled, madam.
No, sir.
Now it is
please
enabled.
check. Okay, sir.
Whether the PPT is visible now?
Sir, wait a minute. It's not. Yeah, now it's visible, sir.
Okay, madam.
Sir, maximize the screen, sir.
Okay, madam.
Okay.
Okay, now it is okay, madam.
Yes, sir.
Okay. Good morning to everyone present here. First of all, I would like to thank the management of PSR Engineering College, principal, dean, head of the department, and coordinator of this ATAL FDP event for providing me a great opportunity to handle one session in this grand event. Thank you once again. Okay.
Thank you, sir.
Okay, thank you, madam. Okay, now I am going to deep into the topic called sensor fusion in robotics. Maybe robotics may be a nonlinear system, or I am going to talk about many autonomous systems also. So here, so today's agenda of my presentation is we are going to see about the origin and definitions of sensor fusion and how the sensor fusion is used in autonomous systems. And the third one is we are going to see about 4 ways of needs involved in sensor fusion and examples for understanding purpose why we go for sensor fusion and how we need to do sensor fusion. So then we will see some basic architectures involved in sensor fusion and some techniques involved in sensor fusion. Then I'm going to have some slides regarding how to model sensors like a gyroscope sensor and proximity sensor in Simulink. Then afterwards, I'm going to implement my sensor fusion techniques with the help of a nonlinear physical system, famously known as Segway system or inverted pendulum. So here I mentioned that two-wheel inverted pendulum or Segway system as a robotics or physical system. So physical system is nothing but a combination of mechanical parts and electrical parts. Nowadays, the robot is a combination of domains like mechanical, electronics, computer, and with cyber security also. So it is going on extending their version in the forthcoming days and in future. Okay. Okay, first of all, in basics, these are the sensors available in human beings. I think we are aware about these sensors basically available in our human beings like eye. Eye is nothing but an imaging sensor or camera of our human being. And hearing is nothing but a microphone. Microphone in a phone, in a cell phone we are having some microphones. So like that we are having some microphones in that in our human beings. And smell is we can smell some fragrances based on our nose present in our face. So another one is taste. The taste we will we can aware about the taste of anything, any food based on our tongue. So these and touch is in our hands. We can able to touch and understand what is the material present here, even though we don't have any eyes. The blind people can also understand with the help of touch what is the size of the particular object and the shape of the particular object. Like that, they can able to visualize with the help of touch, and it will send some information to the brain. So all these sensors in human beings will send some information, or we can able to tell it otherwise as data. So data is a very important thing in all fields. Nowadays, many courses related to data science and artificial intelligence, data science, many things are data analytics, many things are going around the world. Oh, okay. Here, what I'm going to tell means, if we are walking in a road, without this sensor, we can't able to walk perfectly in the road. sometimes in the opposite side, some car will come, some cycle will come, anything will come. So both eyes and ears, ears will sense the bell ring of the bicycle or horn blowing from the car. Like that, it will sense. So it is a collective data. So the brain will observe all the collective data from all the sensors like eye, nose, ears, tongue, and touch. So the brain will get the combined data. So here itself, a fusing is happening in our human body itself. So there is nothing but a data fusion. So all the sensors providing some data information continuously to the brain. So the brain will continuously read all those sensor data and it will act and it will react. So react means if we walking in a road, some bicycle is in opposite side, it is going to hit within 1 second or 2 seconds. What happened? The brain will react. So brain will react and you will stop, or otherwise you will move to the corner of the road. So the brain is reacting. So brain is nothing but a controller of the entire things present in a human being. So here the sensor acts as an input device and the brain acts as a control device, and hand and the leg are acts as a actuator. Actuators means they are producing some output or they are giving some responses. So here itself, if any of these sensor failed in our human being, means what will happen? The accuracy will missing. If we lost our eye, means what happened? We can't able to walk with the confidence. By hearing only we will walk. By touching something we will walk. So if we lost any sensory elements in our body, means our body will lose some confidence and our brain will not get any accuracy information. So all these sensors are needed to produce a perfect output by the human body. So here itself, the word sensor fusion has born. This is my idea about sensor fusion. I think now you can aware about what is the sensor fusion. So the next slide, I'm going to say about what is sensor fusion and where it is originated. Okay, see here, multi-sensor fusion. Multi-sensor means we are having many sensors, like for example, if we are going to design one obstacle avoidance robot, means in that we are having some IR proximity sensor, then gyroscope sensor, then temperature sensor, then distance measuring UV sensor. So there are thousands of sensors are available in the market. So gas sensor is also there. So many sensors are there. So we are going to fusing the data of those sensors. So only the term multi-sensor fusion is coined. So the multi-sensor fusion is also known as multi-sensor data fusion, which is an emerging technology originally catered for the military needs such as battlefield surveillance, automated target recognition, remote sensing, and guidance and control of autonomous vehicles. In recent years, the multi-sensor fusion technology has been extensively applied to a variety of civilian applications such as monitoring of complex machinery, medical diagnosis, and smart building, robotics, video, image processing, and intelligent system design. So these are the applications based on the multi-sensor fusion. So I get this information from the following literatures like D. Hall, the author of this particular article on an introduction to multi-sensor data fusion proceedings of IEEE. It was published in the year 1997 itself. And another article, the author name is Kalgi and Kamis, state-of-the-art technology. They are reviewing about this multi-sensor data fusion in the year 2013. So these are the originated years of the multi-sensor fusion. Now we move on to the next slide. So the definition, the proper definition occurs from the literature. The essence of multi-sensor fusion technique is to combine data from multiple sensors and related information from associated database to achieve the improved accuracies and more specific inferences that then could be achieved with the use of a single sensor alone. Okay. So many definitions are there. For understanding purpose, I am mentioning these type of definitions from the literatures. Okay. Then problem solving techniques based on the idea of integrating many answers into a single one. Finally we will get the best sensor. In optimization process also, what we will do, we will combine many things and finally we will get only one optimal value. So likewise, there's problems. Likewise, the sensor fusion is going on. Then process of combining data or information from various sensors to provide a robust and complete description of a process of an interest. Then multi-level process dealing with automatic detection, association, correlation, estimation, and combination of data or information from single or multiple sources. Okay. So after reviewing those literatures and many definitions, I come to the conclusion that combining two or more data sources in a way that generates a better understanding of the system, more consistent, more accurate, and more dependable. While we are combining many data sources, for example, if we combine a single type of sensors, for example, if we are having one temperature sensor, but we will first we are reading that particular data from particular temperature sensor, it will give some value. But again, we are using second sensor. For example, in COVID also, in COVID, for checking the temperature, now they are using the thermal scanner for monitoring the temperature. But sometimes it will give false data. If we have only one, means it will tell only sometimes it will give false data. Otherwise, if we have two or more thermal scanner to monitor the temperature, means it will give accurate data. How means it will make we will do some averaging between these sensors, averaging function of the output. So only sensor fusion provides a more consistent, more accurate, and more dependable output. So here the sensor fusion will combine many sensors data, combine the data from many sensors, and it will provide us output as acceleration or distance and any system state. So it's a general block diagram to explain the sensor fusion. So again, one definition, the sensor fusion is the process of merging data from multiple sensors such that to reduce the amount of uncertainty. Uncertainty means we can't be able to predict the future. So we can't be able to predict the event, what will happen in the next fraction of second. So for that purpose, if we do sensor fusion, means we can be able to reduce the amount of uncertain actions happened during any autonomous systems like robot or any machinery. Okay, the sensor fusion helps in building a more accurate world model in order for the robot to navigate and behave more successfully. So here I need to mention one thing. If we have sometimes while we are using sensors in airplane or anything, if the military tank, if we use some sensors in military tank, but after 1 day or 2 days it gets failed. What get failed means that particular sensor will not work in a critical situation. At that time, the sensor fusion algorithm will have a model. Model means it already had a physical world model based on the sensors and based on the GPS location and based on the circumstances. It will have some database and it will react on that time to tackle the critical situation. Okay, so we will see that some examples why we are going for sensor fusion and how it is helpful in the next future slides. Okay, next we are going to that part only. Sensor fusion in autonomous systems. Sensor fusion in autonomous systems. Here, how does the sensor fusion helps in the design of autonomous systems? So what is meant by autonomous systems? Autonomous systems means there is no intervention of human behavior. So there is an absence of human behavior, because that particular system will get data through sensor and it will react with the help of microcontroller or any processor present in it. So for that we need more types of sensors. For example, Google cars and Hyundai also developing some autonomous cars, and nowadays, recently, before 2 weeks back, I saw in news then taxi in Russia, autonomous taxi in Russia. So these devices have sensors like LIDAR sensor, laser sensor, infrared sensor, UV sensor, and camera and radar sensor. So these, why we are having so much of sensor? Nearly, for example, an Opel Corsa car having nearly a 1050 sensors attached with the car. Why we are having such great extent of sensors means to maintain accuracy, because car means it's not a general purpose, because it is going and meet real-time constraints. Because if you are running a car in the road means so many persons will come as a hindrance. So many cars or persons or bicycle riders, they will come nearer to car or back door or back of the car or side of the car or 45-degree angle of the car. So in all sides they will come. So at that time, that particular car can move without hitting anybody. So we are having lot of sensors inbuilt with such an autonomous cars. Here, the first block explain the physical world. The physical world is nothing but here the road scenario, whether the road, the particular road is very traffic, or it is free, or any neighbor car is there, or any car in front of my car. Like that, it will analyze the physical world based on the available sensors in the car. So these sensors will provide data that is called collect data. So that is the second block, collect data. Sense means based on the sensory circuits, they will collect data. In sensors, I think you are aware about embedded systems. We have studied about analog to digital converter, digital to analog converter. What happened? For example, if a temperature, for example, I need to quote an example with the help of temperature sensor LM35. In a LM35 temperature sensor has 3 pins. One pin is VCC and one pin is ground, and the center pin is output. If we provide some heat with the help of matchbox to that LM35 sensor, means that LM35 sensor will give some variation in the output signal. The 5 volt will vary. So the electrical signal gets varied. After, with the help of analog to digital converter, we will convert that into digital signals. Okay. So for 5 volt, the corresponding value for digital is 1023, I think, because I am an embedded system engineer. So when I am working with the help of any process using hyper-terminal window, we can able to see the collection of data through sensors. So it will convert those analog values into digital values. After that, we will write some programs to convert that temperature electrical values into temperature values, like 35 degrees Celsius, 25 degrees Celsius. So the collecting data. So that is the first process. Then perceive. Perceive means we need to realize those information, or we need to understand what we gathered through sensor, what type of data we have gathered through sensor. Like that, we need to realize, or we need to understand about the collection of data through sensors. So that is the process called interpret data or perceive. Nothing but realizing the value of particular data. Okay. The next one is plan. So after receiving the data and understanding the data, we need to plan with the help of any processor only. So that is find path. So the car is going to move a kilometer, 1 kilometer, 2 kilometer. It will understand if there is no obstacle, means that particular autonomous car will move. Otherwise, the particular autonomous car will not move. Okay, so that is the plan. Okay, then afterwards follow path. First it will plan within a fraction of a second. After planning, the particular car will move. So the follow path. So sense, perceive, plan and act. So these are the things happen in our human body also. Sense, perceive, plan and act is in our body also. That thing only we are mimicking to the autonomous systems also. Okay. Okay, in the next slide, what they are going to come to the conclusion is, it is nothing but a control engineering. So the sensor fusion is in the control engineering, we need sensors. For example, the control engineering, we need sensors and controller and actuator and a feedback part is needed. So this is the control system block diagram. The physical world, collect data, interpret data, find path, follow path. After follow path, we need to check. After taking step forward to 1 meter, we will check whether again it will check. Continuously, it will continuously monitoring the data. Okay, with the help of one data alone, the car cannot move to a certain distance. Continuously it gets monitored for each and every second. The sensor will send some data and understand, and then it will plan, and then it will act. So each and every second is going on based on the feedback loop. Okay, I think now we can better understand about the involvement of sensor fusion for controlling the autonomous systems. So the self-awareness means localization and positioning. Localization is nothing but the position, where it is, the car, the localization positioning. And situational awareness means detection and tracking. Detection and tracking means whether the car, whether any obstacle is there in front of the car or side of the car, like that, it will detect and track. So here the main important thing is the second and the third block diagram. The combination of the second and the third block diagram is nothing but sensor fusion. Sensor fusion means it will first collect data and understand the data. Sometimes if the sensor is absent, sometimes the sensor is failed to collect data, with the help of interpret data, it will work. It will work in the critical condition based on the previous data analysis. So the sensor fusion is nothing but a collection of data and also understanding of data. So it is called sensor fusion. So the next slide is, we are going to see the need and the examples. I think after seeing these examples, you have better understood about the sensor fusion and why we go for sensor fusion. 4 ways of sensor fusion need an example for understanding. Okay, we are going to see about these 4 ways. It can increase the quality of data. That means we are combining many sensors, means what happened? The quality of the data will increase. And reliability. Reliability means we can be able to believe that data. Then it can estimate unmeasured states also. It can increase the coverage area also. Okay. So these are the 4 things. For the first thing, we are going to see one example. Wait a minute. Okay. The first way is it can increase the quality of the data. For that, I introduced one example, an accelerometer and a table. Accelerometer. Accelerometer, we are having this accelerometer nowadays in phone and in cars, in all the things we are having this accelerometer. So consider an accelerometer sensor for fusion technique here. If we have a single accelerometer on table, output will be generated with some noise. So any circuit device, we have an ideal case and a practical case. In ideal case, the noise is not there, but in practical case, the noise will be present. So when depend upon the real-time scenario, some disturbance will occur for each sensor. So here also some noise affects the accelerometer sensor data. If we add extra one accelerometer to the first one, the noise will be reduced by averaging the output of the two sensors. So this is the process carried out by sensor fusion. Okay, so we will see with the diagram. Before that, we will see one type called fusion with correlation. Why with fusion with correlation we are discussing here means, here we are going to discuss with the homogeneous type of sensors. Homogeneous means same type of sensors. We are not dealing with proximity sensor with gyro sensor. We are dealing with same type of sensors like accelerometer. One accelerometer is combined with the second accelerometer is combined with third, like that we are going on. So it is a homogeneous type we are seeing now. So for that, we are going for a condition called fusion with correlation. What is it by correlation? Correlation is nothing but something relation between the two sensors or two things. There are mutual relation. We can able to tell the mutual relation between the two sensors or two things. Here we are discussing about sensors only. So we are going to analyze about the common things or connection materials between the two things. So that is called fusion with correlation. So I referred some literatures like in the literature, this limitation has been overcome by where an optimal information fusion criteria was derived the linear minimum variance since with the help of Lagrange multiplier. On the mathematical point of view, this fusion rule is equivalent to the best linear unbiased estimation fusion rule or weighted least squares fusion rule. Okay, we will see in the next example about this, what is fusion with correlation with the better examples. So these are the formulas for multi-sensor fusion rules, that correlation formula and independent formula. You can take down this formula. So now I'm going to explain with an example. See here, we are having a table and one accelerometer on that. The accelerometer we are getting 9.81 meter per second square acceleration. So these are the graph. These are the values. These are the data values. But data values have some oscillation. Oscillation means there is no constant line. So that has some sustained oscillations. We can able to tell sustained oscillations or some sine wave like oscillation, oscillatory. So that oscillation is called as a noise affected part. So the optimal range is 9.81 meter per second square, but we get the particular oscillometer waves depend on the 9.81 meter per second, but sometimes it moves to up and down, moves up and down like oscillatory. So it seems to be an involvement of noise. So at this time, we can be able to get the accurate information with the help of one sensor. So we go for merging two sensors, two same type of sensors or homogeneous type. So we are keeping another one, that means second accelerometer, and combined with the first accelerometer, we get two waves. So we get two waves, but two waves have some correlation factors, correlation values. Correlation values means same, some interconnection, some connection between the two outputs. So both outputs are based on the optimal reference input 9.81 meter per second square only, but both the accelerometer have some noise affected values. So to avoid this, we are going for sensor fusion. Sensor fusion is nothing but we are going to make an averaging between these data from accelerometer. See the next one, the next slide. The next slide, with the help of sensor fusion, we are averaging. So averaging the accelerometer data. So after averaging, the noise gets reduced. See here, I make one calculation. 4 sensors equal to half a noise. So if we combine 4 sensors, means we will get 1/2 noise only, half noise only. So the noise gets reduced. If we have a single sensor, the noise will be more. If we combine 2 or more sensors, the average, we will get the accurate average, and the precision will be happened. So I think you have better understood about the combination of 2 homogeneous sensor and why we go for sensor fusion. Okay. So the next one is previously we called fusion with correlation. So here we are dealing with the correlation values, correlation sensor. That means correlation means some common thing between the 2 sensors. That is called correlation. But here we are going to deal with unknown correlation. Sometimes there is no correlation. If we have the homogeneous sensors only, but one accelerometer will provide 9.1 meter per second square, and another accelerometer will produce some values for 8.8. So that is called unknown correlation. So there is no correlation. So at that time, when this kind of problem will occur, means lack of knowledge of the true system. Okay, too difficult to describe. So these are the 2 advantages, the disadvantage: lack of knowledge of the true system, too difficult to describe. The first one is lack of knowledge of the true system. The correlation cannot be identified. Example, correlations from observation noises, as I didn't identify some noise. Sometimes we can't be able to understand the we can't be able to understand the behavior of the noise. So where it is, behavior of the noise or source of the noise, where it is come from, some problem will occur. So that is called unknown correlation. Okay. So at that time we need some filter implementation. With the help of filter, we can be able to avoid some noises. So these are the literatures I have obtained some information based on the fusion with unknown correlation. Okay. So then too difficult to describe means involve too many variables, thousands of states may be used in the applications of map building, which means maintaining an accurate covariance is impractical. Data incest or double counting problem, where information is advertently used several times due to the presence of network groups in distributed fusion settings. Difficult to calculate. For example, how to acquire reliable correlations in nonlinear estimates is still an open question. Okay. So summarily, it is widely believed that the unknown correlations are ubiquitously existing in a diverse range of multi-sensor fusion problems. Neglect the effect of unknown correlations can result in grave consequence of performance deterioration, even divergence. As such, it has attracted and sustained attention from researchers for decades. However, due to its intricate unknown nature, it's not easy to come up with a satisfied scheme to address the fusion problems with unknown correlations. So it is one of the problem in sensor fusion. For this, we can do some research. So these are the mathematical terms related to known correlations, unknown correlations, and no correlations. Okay. So the next one, we are going to see fusion to no correlation. No correlation means we are dealing with heterogeneous sensors. So we are going to deal with heterogeneous sensors. So I am going to deal some example for heterogeneous sensors. See here. So this is mathematical. So now I am going to explain based on the magnetometer. Magnetometer means what? In a cell phone, we are having magnetometer means it will tell the magnetic compass. It will tell the direction, whether it is north or west or east, south, like that it will tell. So if we combine the instead of combining the two homogeneous sensors, in some cases like mobile phone, we will combine some heterogeneous sensors to reduce the noise. So that kind of case we are going to see here. For example, in we are having a magnetometer in mobile, we are getting a graph like this. See here, angle to the north, we are getting a graph like this. So this is the output of the magnetometer or response of the magnetometer. Okay, for example, the same what we have did in the homogeneous type of sensor fusion, what we have did, we add another type of another magnetometer to make average between the two outputs of the magnetometer and then get the precise values to react. So like that here also we are doing. See here we are having two magnetometer in the mobile. After that, we are combining the values of two magnetometer by using the averaging function in the sensor fusion. Even though we do the averaging function, we can't able to get accurately. Why? Why means in mobile phone we are having many electronic circuits and antenna is also there for sending for transmitting information from one place to another place and also receiving encoder decoder is also there. So at that time what happened, due to that presence of electronic circuits also, some magnetic waves will go around, some radiation will go. So at that time that acts as a noise to that multimeter, acts as a noise to that multimeter. Okay, so that acts as a noise, acts as a noise to the magnetometer. So see here in the next case we are going to see that one. See, there are two magnetometers. The yellow lines, the yellow curves denotes the noise. Denotes the noise arises from the electronic circuits, other electronic circuits present inside the mobile phone. So electronic circuits present inside the mobile will produce some magnetic noise. So it will add some noise to the output of the magnetometer present inside the mobile. Therefore, the averaging the output of the magnetometer won't help to avoid correlated noise. So this is a peculiar case in merging the homogeneous sensors. So based on the application, here the application is smartphone. The smartphone we are having a magnetometer to point out the directions like north, south, west. So for that we are having, but other circuits are also present. So due to that circuit, some noise will be generated. Wait a minute. Wait a minute. Okay. Okay, to avoid this problem, we can use low pass filter to avoid noise or fuse the magnetometer sensor with the gyro sensor. So here we are going to discuss about another type of sensor called gyroscope or gyro sensor or MEMS gyroscope, microelectronic mechanical switch. Nowadays they are often used in all the games in cell phones and robotics also they are using. So while we are merging different heterogeneous sensors means this noise problem will correlate, will be solved. So in the next case, reduce noise with the two different types of sensors. How? In the first case, we can use low pass filter. With the help of low pass filter, we can eliminate the noise. So in which case means if there is an absence of noise from the circuits from the cell phone, from the mobile phone, means we can able to eliminate based on the low pass filter. But if any noise occurs from the cell phone, means we can we can combine the gyro with the magnetometer. So it is a combination of two heterogeneous type of sensors, magnetometer and gyro. So if we combine the results or combine the output of these sensors based on the averaging function, we can eliminate the noise. We can reduce the noise to a certain extent. Okay. So the Kalman filter, the famous word Kalman filter, I think you are aware about. The electronics and communication engineers are aware about the word Kalman filter. Kalman filter is nothing but a sensor fusion algorithm only. So Kalman filter is a sensor fusion algorithm to predict and estimate. So the prediction and estimation process is going on in the Kalman filter. So we will see in the next slides. I think previously we have discussed about the homogeneous sensors. Now we have discussed about why we are switching over to heterogeneous sensors in typical applications like smartphones. To reduce the noise, only we are moving to another type. Okay. Okay. So now we are going to move on to the next example for second way. The first way is it can increase the, see here in the slide, the first before we can see that it can increase the quality of the data. For quality of the data only, we have seen about the combination of two homogeneous sensors and the combination of heterogeneous sensor, how we are reducing the noise with the help of sensor fusion. So like that we have seen. Now we are going to see about the second case called reliability, how we increase the reliability in some critical applications like airplanes, military missiles. So at that stage, we need to maintain reliability. Okay, because they are in the critical situation, the particular sensor will not work, means what happened? It's create a great disaster. So we need some, we need to create reliability among the sensor fusion. So see, so the second example, it can increase the reliability also. Sensor fusion can increase the reliability. How? We will see here. I am going to consider one example based on the airplane, any passenger airplane or military-based airplane, anything. So in airplane, we are having some pitot tubes, pitot tubes or pitot tubes. Okay, pitot tubes are there. The pitot tubes are used to measure the airflow speed in the airplanes. So that is nothing but air speed sensors. So it will measure the air speed air speed, how the airplane is going against the heavy flow of air. So if the heavy flow of air means they can run the airplane in a very slow manner and steady manner. So for that, these airspeed sensors are there. So pitot tubes are used to measure the airflow speed in the airplanes. So then here they are introducing some new concepts called voting concept. Voting concept means what? In real world, for example, for in the election and all, we will put vote. Vote is nothing but a large collection of data. For example, in a particular district, we are having 4 lakh population, means nearly 3 lakh populated people get vote, means, and the majority will get elected to the parliament or our Tamilnadu assembly. Okay. So likewise, here also there is some voting concept in sensors. So voting concept is used previously. That means before before finding the word sensor fusion, they using the word called voting concept is used previously to model the collective decision making process. Okay, so in the airplane previously they have some pitot tubes and voting concept to make decision based on the airflow to fly in the sky. So what is the problem behind this pitot tube means sometimes if we have a cold weather, sometimes that particular airplane is fly over the like Arctic Sea and Antarctic Sea, some cold weather or rainy weather means that pitot tubes particularly gets frozen. Sometimes it gets frozen due to heavy rain or cold weather. So it gets frozen means that all the sensors will get failed. So to avoid this problem, sensor fusion has introduced to increase the reliability in such real-time scenarios. See here, if we have 100, if we have more sensors also, but based on the weather conditions and real-time scenario, that particular sensor gets failed. So the sensor fusion is the new technology to avoid those problems in real-time scenario. Here in the below we have one black diagram. It's a general black diagram of before sensor fusion. We are having some voting technique. We are having three pitot tube 1, pitot tube 2, and pitot tube 3. If one pitot tube gets failed, it will get some information or data from other two pitot tubes. If all the three pitot tubes get failed means how the airplane will calculate the airspeed and it will move further in the sky. So for that we are going to see a sensor fusion model. So this is the sensor fusion model used in modern airplanes nowadays. See here, what they are having some model. Already I told here sensor fusion means it will collect information it will collect information before 1 hour or before 2 hours based on the collection of data. That means in the previous black diagram we discussed about sense and perceive. So the third sense and perceive is the combination of sensor fusion. If sense fails, it will work based on the perceived things only. Perceived things means data collection and understanding of things. Okay, so here we are having three pitot tubes voting and airspeed is also coming. Sometimes it gets failed. It gets failed means see here. See, the data will not come here. Okay, whether it is visible? Okay, I think it is the old one. So we are having three pitot tubes and we are having a voting mechanism, and then finally we get the airspeed calculation. But here, due to frozen condition, what happened? Due to frozen condition, the data will not be available to this combination black. At that time it will get activated. At that time this will get activated based on the GPS. Here we will connect the GPS. GPS means global positioning system. It will test the longitude and latitude parameters where the airplane is located. Like that it will give some data. And wind model. So this is the very important thing. The wind model previously it was gathered. Wind model previously it was gathered by the voting before 1 hour or before 15 minutes or before 5 minutes. So this is the wind model developed by the sensor fusion techniques. So now based on the location and the wind model, after combining this, we will get one airspeed value. So it will go here. So we think it will go here. I think this combine is nothing but a OR gate. So OR gate. OR gate means what happened? So OR gate. OR gate means here 0, here there is no data, here there is some data 1. We will consider the data as 1 means what happened? We will get 0 and 1 means OR means we will get 1 only, 1. So some data we will receive. So I think you now better understand about this black diagram, what I have created. Okay, I will run those things. I think I have understood this thing. Okay. Whenever the sensor fails, the perceived thing acts. The perceived thing will provide information to the controller and control the entire airplane. So that thing is happening here. So, okay. Okay, I think you better understand about the concept, how it is increasing the reliability. So, okay, it's a significant one. So, sensor fusion becomes a significant one for airplanes and for military-based airplanes and other airplanes. And any critical scenario, if we need to face any critical scenario, means sensor fusion is very important. Okay, so this is the black diagram of sensor fusion for the second case. So again, another one example I'm going to explain. For example, losing a sensor doesn't mean it failed. So this is another example. For example, for fishermen boats in the sea. So that is flying example. So it is water. So ocean example. Here, if we have a small fisherman boat is going on, some radar. So here we are having some radar sensor is there. This is a radar sensor. So this one is a radar sensor. So see, this radar sensor will send some information to the particular robot, particular boat based on the Doppler shift frequency. I think you are aware about Doppler shift. So it will give some information back to the sensor. So it will understand how much distance that particular boat is there in the ocean, whether it is in the middle of the ocean or it is in the end of the ocean, or it is a particular 50 meter from the 50 kilometer, like that it will understand the distance based on the radar sensor. But in the second case, if you see, means if any large ship like Titanic ship or any large ship or large marine vessels like cargo ships. Nowadays, one cargo ship has get stuck in the Suez Canal. So like this, one cargo ship has come in between the small fisherman boat and this radar sensor. What happened? This radar sensor will reply to this particular cargo ships. It will lost information from the boat. So it's a normal case. But if we have a sensor fusion in the radar, means what happened means it will never lost the information, because already as a model. So it will estimate. So that particular boat is 50 before 5 minutes, that particular boat within 50 kilometer per hour. After 5 minutes, it will move certain distance. Like that, it will predict and estimate based on the perceived information. So see. Okay. So the next slide, it indicates what happening in the real-time scenario, how the sensor fusion is helping for the radar to estimate the distance of the particular particular boat. Okay, we don't need any alternate sensor to work in this problem. Sensor fusion will help in this situation. So here we don't need any extra sensors, but already we are having some model of the physical world. See here in the black diagram, I have the model of the physical world. So this only perceive things. Model of the physical world means it perceive. So it will store information. It has already stored some information. Okay, perceive. So perceive, even if the sensor doesn't work, it is the perceive will react. Here the sensor is working. Here the case is for in the ocean case, sensor is working, but some interferences occurred, some interruption has occurred between the two things, sensor and the boat. So at that time, the radar information is get collected by the perceived. So some data is collected. So that is called the model of the physical speed and heading. Heading means direction. Speed means the particular speed of the boat. Where but the particular boat is going towards east side with 50 km/h means there is some information. So this one is real time world. This one is real time data now. So after that particular cargo ship comes between them. So real world, and this is the perceived thing. Both combine and give the new estimated data correctly, accurate data like distance and rate. So this is the thing what I imposed to tell. Okay. So the next, we are going to the next case. Example for way 3, it can estimate unmeasured states. So here, the way 3, sensor vision, first one is it can increase the second one is reliability. The first one is it can increase the quality of the data. The third one is it can estimate unmeasured states. So we are going to see that one, unmeasured states. Okay. Consider a camera to measure the distance of the remote object, but it fails to measure correctly. See here, if you have only one camera in the car, for example, if you have only one camera in the autonomous car, means what happen? If we see that stop board means it will measure that particular stop board before 15 meter or 20 meter, because sometimes it will can wrongly assume, because the camera can collect the data, collect the picture data, but the information cannot be correct. For example, that if our face is get captured with a particular camera means, if we see in the camera means the particular face is very small size, but really what happened, our face is very big, but in the camera we can able to see in the smaller size. So it cannot be able to give the perfect thing. So to avoid this problem, 2 or 3 cameras are used to capture the remote object and report the accurate distance using sensor fusion techniques. So see here I used 2 cameras. So 2 cameras, based on the 2 cameras, we can able to get the accurate data. So that is nothing but sensor fusion. We are combining the imaging values of 2 cameras and we get the accurate data called distance. So this is another. So it comes under it can estimate unmeasured states. So it is called unmeasured states. Okay, the last example. So the last example is it can increase coverage. What is mean coverage? Coverage means but particular sensor, how it will work. Whether the particular sensor will work for 1 meter or 2 meter. For example, in a project we will ask the students whether this IR proximity sensor will work for how much distance, like that we will ask. That particular IR's distance measuring sensor will work for only 10 to 15 centimeters only, because that is not a real one. We are buying from for the project, the 10 to 15 centimeters only. But for real, that is only 50 or 60 rupees. But if we need to buy a real IR proximity sensor, means they will mention some specifications like range and coverage area and how much voltage it will consume and the current rating, whether it will work in 1 ampere or 2 ampere or 3 ampere, like that they will mention in the specifications or costly sensors. So here I consider an example for automatic parking system. Automatic parking system nowadays in BMW car and Audi cars, the cost of cars, those who are having more than 20 lakhs means they are having this automatic parking system. So without the help of driver, that particular car gets parked in the parking valet. In the 5-star hotel and all, they are having some parking valet with the help of sensors to manage these type of cars. So if we have only one sensor in front of the car, means what happened? What happened? It will cover the areas before the front of the car only. So it will not collide with the front of the car, but it will collide with the back side of the car. And also in the other side, if you have valves, means it can collide, can able to get hit with the side doors also. So to avoid this, we need to use more sensors. So more sensors means we need some fusing capability also. Then only the processor can understand. By averaging the function, only the processor can be able to react based on the averaging sensor values. See here, if the car has 4 sensors on all 4 sides of the car. See, in the previous slide, I have only one sensor in front of the car. But here, we are having many sensors in all sides of the car. So it gets good coverage area. So all the sensors are combined with the help of sensor fusion and average to indicate the accurate registering object. What is the registering object means? If you have only one camera in front of the car, means we will get only one information. That means not accurate information. But if you are having more cameras around the car, means after averaging this, we will identify that particular object is a pillar, or particular object is a car, that particular object is a human being, or any dog, or anything. So we can understand. So for that only we are going for sensor fusion. For that only the autonomous cars having more number of sensors within the car. Okay. So only they are the cost of automatic car is very high. So next, so these are the examples. 4 examples we have discussed what is sensor fusion and why we go for sensor fusion and what are the advantages of sensor fusion in various scenarios like aeroplanes and accelerometer and magnetometer and mobile phone, then ships or cargo ships. Due to the cargo ships, what problem have arising, like that we have see some examples to understand the sensor fusion. I think now we are aware about the sensor fusion and why we are going for and what is the purpose and what are the advantages of sensor fusion. Now we are going to see particularly about fusion architectures and fusion techniques. Okay, wait a minute. Okay. The first slide in the fusion architecture. Fusion architecture means data fusion only. We are fusing the data only. So data fusion requires combining expertise in 2 areas: sensors and information integration. Data fusion is essentially an information integration problem. Data fusion can be categorized into three main classes based on the level of data abstraction used for fusion. Measurement fusion. Measurement fusion means the sensor data fusion. Feature level fusion means behavior, the behavior of the data. So that is feature level. Then decision level fusion means high level data fusion. Only decision will come from the sensor. So like that, we will see the three types. So the first one is measurement fusion. It will directly get data from the sensors. So, and it will sensor 1, sensor 2, sensor 3, n number of sensors we can able to use. With the help of multiplexer, we can combine those values, and that is combined as a data level fusion. And that afterwards, feature extraction based on the data, we can identify the presence of character or presence of behavior. What is present, whether the particular before the car, whether the particular obstacle is there or not, like that we can able to understand with the help of this measurement fusion. So next, feature level fusion involves the extraction of representative features from sensor data. Feature level fusion means in the case of absence of sensor, sometimes that any sensors failed means we will use this thing. We have already seen some cases. So at that time we will use that feature level fusion. Based on the feature, we will act on it. Okay. Then decision level fusion, each sensor has made a preliminary determination of an entity location, attributes, and identity before combining. Decision level fusion algorithms are used, such as weighted decision bias interface and themselves of a Smith. And these are the fusion architectures. Now we are going to see fusion techniques. Data fusion can be classified into three types: data association, decision fusion, and state estimation. So the next, the data association techniques, the process of assign and compute the weight that relates the observation of tracks from one set to the observation of the tracks of another set. So you can see some literature related to data association techniques, then state estimation techniques. So these are the general things and decision fusion techniques. And here, this is the combined tabular column. What are the things used for data association and state estimation and decision fusion? For data association means nearest neighbors, probabilistic data association, joint PDA, multiple hypothesis test. In state estimation only, we are using Kalman filter based on Bayesian approaches only. So these are the technical terms involved in the sensor fusion. So now we directly see the simulation part, how we are perform the sensor, how we can model the sensor in simulation. Okay, I tried this one in the year of 2016. I tried to model the sensor in real time. So at that time, I need some mathematical functions to model. So that paper is published as a conference paper. So it is the origin for me to know about sensor fusion. So next we go about the mathematical modeling of gyro sensor. So gyro sensor, you all know about the gyro sensor means it will tell about the angles like pitch angle, yaw angle, roll. That means x, y, z values. It will give in terms of x, y, z. And nowadays the chip, the third diagram represents the chips, that GY52 gyroscope chip, MEMS gyroscope chip. I have used this MEMS gyroscope chip in many robotic devices like obstacle avoidance, while I am developing obstacle avoidance robot. Then while I am developing two-wheel Segway robot, Segway robot and inverted pendulum concept. At that time, I used this gyro chip. So how we can able to model the gyro output also. See here, a gyroscope is a disc, a spinning circle where at any direction the axis in free rotation. During rotating or bending or twisting, direction of the pole is explicitly predicted on the law of conservation of angular momentum. So the micro electromechanical system gyroscopes are motion sensors that detect and measure the angular motion of an object. Okay. So the transfer function of the gyro sensor. So it is nothing but a transfer function of the gyro sensor means it's nothing but a second order underdamped response transfer function only. In control system, we have studied about the first order transfer function, second order transfer function, third order. In second order transfer function, we deal with the cases like undamped, underdamped, overdamped, and critically damped cases. So here we are dealing with some second order transfer function. So that second order transfer function gives some oscillations. So only I consider this second order as a transfer function for gyro sensor, and I referred many literatures. They have provided this type of mathematical functions for gyro sensor. So and another one is a transfer function for low pass filter to filter the data coming out from the MEMS gyroscope. So I then, with the help of Simulink in MATLAB, I drew this diagram for simulation purpose to analyze the output of the gyroscope. See here, and also I introduced some noise also, band limiter white noise, to provide noise to the ideal case. Then only you can able to understand the gyro output. See here, the first big black has some transfer functions, second order transfer functions, and it will get the after making such a Simulink, and here we are having low pass filter also. See here, this is the transfer function of, this is nothing but the transfer function of gyro, and this is the transfer function of nothing but low pass filter. I am adding noise also here. Then only it will get filtered by the low pass filter. Finally, we get the filtered output. So I analyzed it before noise and after noise also, before filter and after. Here, if we take the output here means we can able to analyze the noisy output. After that, we can analyze the noiseless output. So we will see in the next slide what we have get after doing this Simulink blacks. Okay. See, so first see the first graph denotes the noisy output of gyro sensor. So the gyro sensor is nothing but it will detect a motion. If we move the cell phone, the gyro sensor is present in the cell phone. For example, nowadays, for example, the car game. We are moving the particular car to left side, or we are moving the car to the right side. Means we need to shake the cell phones. Shake the cell phone to right side means the car will go to the right side. If we shake the cell phone to left side means it will go to the left side. Those games are based on this gyro sensor only. So first of all, I add some noise. So only we get the gyro values with some noise. Noise means oscillatory part only. But after giving some low pass filter, some noise gets reduced. See here, the second graph, we are having some noise gets reduced. So this is the second noiseless output of the gyro sensor based on the low pass filter. Here we are not talking about sensor fusion. Yeah, we are talking about only sensor. How we are modeling those sensor in Simulink. I am giving some idea to the PG students and other research scholars how we need to work in sensors. Okay, in simulation part. Okay, next one is, next we are switch on to the next sensor called IR proximity sensor, infrared proximity sensor. So in infrared proximity sensor also I have attained some transfer function from various literatures. I have reviewed in the year of 2016. I got those transfer function for slow dynamics and fast dynamics. So what is the dynamics? I think those studied mechatronics and mechanical subjects are deal with robotics means they better known about dynamics and kinematics. Here I need to quote what is dynamics. Dynamics means study of motions that result from forces. Study of motions. Study of motion means if we are hitting the particular chair means what happened? The chair will move to a certain distance. That is called displacement. That we call as displacement. How that particular chair moved to a certain distance? I am providing the force with the help of hand. So with the help of force, some object gets moved means that is called as dynamics. So the proper definition is study of motions that result from forces, that is called dynamics. But kinematics is entirely different. Kinematics means study of motions without regard to forces. So that what they are mentioning means, for example, without providing force, for example, ball, a tire, without force, how it will move. Without force, what are all the things are present. So like that, we are analyzed means that is called kinematics. Kinematics for stationary, when the car is in the road, the car is standing on the road means we deal with kinematics. If that particular car will move on the road with certain acceleration values means we deal with the dynamics. So this is the difference between the dynamics and kinematics. So the slow dynamics and fast dynamics means dynamics is nothing but a motion of object result from forces if the force is very low. For example, here I compare the slow dynamics and fast dynamics with PWM pulses. What is the PWM pulses? Pulse width modulation. Pulse width modulation means it has T on and T off. So the time on and time off. Time on means for certain 2 milliseconds or 3 milliseconds, that voltage will rise up to high level, 1. The case is 1. After 2 milliseconds, it will go to the low and attain 0 volt. So 2 volt, 0 volt, 2 volt, 0 volt, it will go on. So that 0 volt is called slow dynamics, that 2 volt is called fast dynamics. Why we are having this combined parameter? Because in a car, to maintain a speed of 50 km per hour, we need both the dynamics. Because, for example, if we constantly touching the oscillator pedal in the car means what happen? It will continuously increase. It will first 10 km, then 20, 30, 40, like the acceleration speed will increase. So, but here the case we need to maintain in the level up to 50 km per hour. So at that time, what happened? We will first give some push to oscillator. After that, we will leave. After that, we will push again. We will leave. So we will maintain some speed. So at that, likewise, in the autonomous cars also, we need two types of autonomous cars also we need two types of speeds, slow fast. Then only that car will maintain at a certain reference speed. So here, so based on that, we are having the fast dynamics and slow dynamics in the IR proximity sensor. So based on that, we are both I used both slow dynamics and fast dynamics. I have designed this Simulink model in the MATLAB. Afterwards, so and also here I am introducing some noises also. So these are the simulation thing. Why we are going for simulation thing means to understand the characteristics of particular sensor, how it will work, or what is the output of sensor. To understand that particular thing, we are going for soft sensor modeling of sensors. So this is the best term to correlate the simulation. So finally, I get a noisy output of proximity sensor. You see that particular thing. You can see this part alone. So here I give and again in the value, so it will come here. So see here, we need to get the output 2.56 nearly. So we get first initially it will get rise time. So overshoot has happened. So overshoot has happened due to the presence of noise. After that, it gets saturated at the level of 2.56. Okay. But even though there are some oscillations present, so these oscillations can be considered sustained oscillations because it gets saturated to the value between 2.53 to 2.55 to 56. So, okay. Okay. This is a noisy output. After providing the filter with RC filter, see here, before scope, there is no filter. In this simulating diagram, we are using some RC filter. So after introducing this RC filter, we get the IR proximity modeling with RC filter. We get a nice output. See at 2.5, the same 2.5. After applying the filter, we are getting the fine output. It gets saturated at the value of 2.56 or 2.55, I think so. I think better understood here. See the value of 2.5. We are getting the steady state condition of the proximity, IR proximity sensor. So here, until I discuss about the modeling of individual sensors. Now, recently, I wrote one paper by combining these sensors for Segway system. So next we will discuss about that paper. Okay. So now we are moving on to the real-time case. How we are going to implement these sensor fusion in a real-time system or robotics or any physical system. So here I am going to tell about some introduction about inverted pendulum. So inverted pendulum. So it is a benchmark system. I think those who are well versed in control system, they are aware about this inverted pendulum because it's a very standard benchmark model. Before 50 to 100 years, they are having this kind of system. So the inverted pendulum is the basic concept for launching the rocket, because the rocket is considered as a pencil for the Earth, but how it is stabilized and moving to the space orbit. So these are all the basic things for the inverted pendulum. Here we are going to see about wheeled inverted pendulum. Wheeled inverted pendulum is nothing but a Segway robot. I think whether you have seen some movies like Dasavadaram or the Tamil movie Dasavadaram and or any other English movie, you can see that Segway robot that Kamal Haasan is riding with a Segway robot with 2 wheels without balancing, because that particular robot will get balanced with 2 wheels itself. So that particular robot has IMU sensors, inertial measurement unit sensors. IMU sensors, the category of IMU sensors is nothing but gyroscope and the accelerometer and magnetometer coming into the category of IMU sensors. Okay. So here we are going to inverted pendulum means the basic thing is cart position and pendulum angle. So we need to maintain the pendulum angle as an upright position and cart position. We need to maintain the cart position also. So the 2 things we will need to control in this Segway robot or wheeled inverted pendulum. Okay, self-balancing robot. Okay, anything. So the next one is here we are particular to the Kalman filter and particular to what we are going to do with the help of sensor. So this is in my idea. So what I have implemented in my journal article. So the handpiece-based sensor fusion design for self-balancing vehicle. So this is the title I want. The robotic system may execute several control strategies in various proximity levels based on the performance of data fusing algorithm. Based on the data fusing algorithm only, the robotic system may execute the control actions. So see the first black diagram. The name of the first black diagram is sensor fusion between heterogeneous. Sorry, there is some. Correct only. Correct only. Sensor fusion between heterogeneous sensors. Why we mention heterogeneous sensor means UV and ultraviolet sensor is not combined under the category of IME, and IR sensor is also not come under the category of IME. So both are heterogeneous. And in the second diagram we are having accelerometer and gyro. Both are inertial. So both are IME sensors. Both comes under the category of same type of sensors. So they are called as sensor fusion between. So I consider this type of category for using, because in Segway robot here I am using gyro sensor, accelerometer sensor, UV sensor and IR sensor. So only I am using this kind of sensors. Okay. Here the accelerometer sensor and gyro sensor is the same type. So only the same type means inertial measure, IMU type. Okay. So here I am using ANFIS. ANFIS is nothing but adaptive neuro fuzzy inference system. Why I am using this means for the fuzzy is nothing but a knowledge-based approach. Basically, fuzzy is nothing but a knowledge-based approach. It's a collection of knowledge, collection of users' knowledge. Likewise, here the ANFIS acts is a collection of knowledge from sensors, two types of sensors, either it is heterogeneous or homogeneous. So, after collection of data, it will provide some estimated data. Then it will provide the Kalman filter. The Kalman filter gets refined the data and it will provide the final output. So the Kalman filter estimates orientation angles using a false sensor axis contribution with IME. So the Kalman filter plays an important role. But why we are going for ANFIS? The ANFIS will tuned. Okay, the fuzzy, what will the fuzzy? Fuzzy will avoid uncertain situations. So the fuzzy is very helpful to avoid uncertain situations. So uncertain conditions. So it is an additional feature for Kalman filter with ANFIS to provide the better output for Segway system. So the next, the algorithm, we are seeing some algorithm steps or pseudocode steps, how I perform. The algorithm applied to data vision is follows: accumulate information from individual sensor device, evaluate the root mean square value allied along with the sensor data. Data means data from each sensor device. Generate a fuzzy engine along with the encoded input-out parameters by means of ANFIS. The input of the fuzzy engine is data from the transducers, and the final output result of the fuzzy engine is original distance value calculated manually. So these are the steps. Repeatedly train the fuzzy engine up to enhancement not recorded in the present. Fuzzy engine we will train until the accurate value will attain. We will train those engines. So check whether, so likewise we are repeating the step. If not satisfied, repeat step 4. If condition satisfied, halt training and set up the fuzzy system engine with the hardware. This algorithm utilizes a system focused on ANFIS to combine several sensor data. This method let the fuzzy program find the appropriate most appropriate rule base. So these are the steps. So and these are the diagrams what I have obtained. The ANFIS trained data of homogeneous sensor. So in MATLAB we have ANFIS toolbox is there. In MATLAB we have ANFIS toolbox. A fuzzy toolbox is also there. With the help of that only I provide some values from sensors, and I get this type of ANFIS kind of homogeneous sensors and heterogeneous sensors, and this is a structure of homogeneous sensors and heterogeneous sensors what I have obtained. So this is a real-time scenario. So finally this is the output after control. After controlling, I am getting the output like this for a pendulum response. So then there are two types now, the cart position and the pendulum angle. So I get this perfect output based on sensor fusion. So this is the overall of my research area in sensor fusion. I think this is in preliminary stage only. I will continue my research. Okay. Afterwards, I will do some performance analysis based on RSME and MAP, but I didn't mention that table of column in this PPT. So I will. So the Kalman filter, I think most of them know of the Kalman filter. So I left this Kalman filter to you because yeah, we have discussed a lot about the sensor fusion and sensor fusion techniques and why we are going for sensor fusion. So like that we have discussed. So here I mentioned some definition and I am going to show some video to understand the Kalman filter. So it acts as a algorithm in sensor fusion, most important algorithm in sensor fusion. So the Kalman filter is an algorithm that provides estimates of some unknown variables given the measurements observed over time. Kalman filter have been demonstrating its useful in various applications. Kalman filters have relatively simple form and require small computational power. In statistical and control theory, Kalman filter is also known as linear quadratic estimation. In control system, we deal with LQR, linear quadratic regulator. So that is regulator. Here we are estimating. So that is nothing but a Kalman filter algorithm. This is a series of measurements observed over time containing statistical noise and other inaccuracies, produced estimates of unknown variables that tend to be more accurate than those based on single measurement alone, by estimating a joint probability distribution function. Because the estimation is nothing but a probability. So it will estimate the future one, predicted based on the past one, it will predict. So the filter is named after Rudolf E. Kalman, who was one of the primary developed this one. So now I am going to run one video to understand the Kalman filter very clearly. The
Today we'll discuss two examples that demonstrate how the use of research. In the first example, estimate system state when it cannot be measured directly. To illustrate this, let's go to Mars before anyone else does. If your spacecraft
Prabhakar sir, sir, your voice is not audible.
Ma'am?
Sir, now it's audible, sir.
Ma'am, now I am running this video, madam.
Okay.
Okay.
There is no sound.
Now it is coming, madam. You can check.
Okay. Okay, sir.
Extremely tested 500 degrees Fahrenheit. But be careful because at too high temperature, the mechanical components of the engine at risk. And this can lead to failure of some of the mechanical parts. If that happens, you might be stuck with your small spacecraft where you got to eat from tubes. To prevent such a situation, you should closely monitor the internal chamber. This is not an easy task since the sensor placed inside the chamber meant. Instead, it needs to be placed on a cooler surface close to the chamber. The problem you're facing here is that you want to measure the internal temperature of the chamber, but you can't. Instead, you have to measure external temperature. In this situation, you can use a chronometer to find the best estimate of the internal temperature from an indirect measurement. This way,
you're extracting the information about what you can't measure from what you can. Now that you know the solution to your problem, you can continue your journey to Mars. But are you scared of Mars? You're gonna weigh 62% less than what you weigh on Earth. Still not convinced? Okay, then let's go back and take a look at another scenario that takes place on Earth. In this example, we're going to see how a problem filter can be used to estimate the state of the system by combining measurements from different sources that may be subject to noise. You have gases from all agencies, and you need to pick them up from the airport. You're using your car's navigation system. Let's look at the sensors you have on board, which help you find your position and navigate you to the airport. The inertial measurement unit uses accelerometers and gyroscopes to measure the car's acceleration and angular velocity. The odometer measures the distance traveled by the car. The GPS receiver receives signals from satellites to locate the car on the surface. If you live in Boston as I do, you've got to travel through the Big Dig, a very, very long tunnel. And in the tunnel, it gets harder to estimate your position through GPS, since the receiver's line of sight to satellites is blocked and the GPS signal is weak. In this case, you may want to trust the IMU readings, which give you the acceleration. However, acceleration itself doesn't tell you much about the car's position. For that, you need to take the double integral of the acceleration. Fortunately, this operation is prone to drift due to small errors accumulating over time. To get better position estimates, you can use IMU measurements along with odometer readings. But note that odometer measurements may be affected by the tire pressure and road conditions. To summarize, your sensors measuring the relative position of your car give you fast updates, but they are prone to drift. The GPS receiver provides your absolute location, but it gets updated less frequently, and it may be noisy. In this scenario, a common filter can be used to three measurements to find the optimal estimate of the exact position of the car. Let's look at some facts about Kalman filters. Kalman filter is named after Rudolf Kalman, who is the primary developer of this theory. It is an optimal estimation algorithm that predicts the parameter of interest, such as location, speed, and direction, presence of points and measurements. Common applications of Kalman filters include guidance navigation systems, computer vision systems, and signal processing. One of the first applications of Kalman filters was in the 1960s. Do you have any guesses as to what it helped with? Engineers used it in the Apollo projects, where the Kalman filter was used to estimate the trajectories of the manned spacecraft to the moon and back. Let's summarize what we've seen in this video. Kalman filters are used to optimally estimate variables of interest when they can't be measured directly, but an indirect measurement is available. They are also used to find the best estimate of states by combining measurements from various sensors in the presence of noise. In the next videos, we'll cover what Kalman filters are and how they work. Kalman filtering is a method to design optimal state observers. Therefore, in the next video, we'll learn state observers, and then we'll continue our discussion with optimal state estimators.
Okay.
Thank you, sir. Dear participants, do you have any clarification? Please click the hand option.
Participants, do you have any questions?
Sir, wait, sir. They're asking.
Okay.
Just wait, sir. Participants, any clarification? Type the question now. Chat box also. Sir,
Okay, madam.
what is a cloud data fusion?
Cloud data fusion is nothing but- Here we are talking about sensor data fusion.
Yes, sir.
Cloud, I didn't work in that area, but based on cloud computing, we can receive data, I think so.
Okay, sir. And then how do you fuse two sensors?
Only data, madam. For example, we are having some proximity sensors. And proximity sensors, while we are connecting to microcontrollers, it will send some information, data values in terms of electrical signals. So based on that electrical signals, we will combine data only. So by combining the data, we can able to fuse them. For that only I make one simulation part. And simulation part, I model sensor, and then the frame form that model in the simulink, and then I make. But here individually, I made some sensors. Hello.
Sir?
Yes,
one
we
more-
can use more than 2 sensors also.
Okay, sir. Okay, sir. Is there any technology or any simulation tool to add more sensors?
I particularly mostly work in the MATLAB. So in the MATLAB itself, we are having many things are there.
Okay, sir. Question from participant side. ANFIS gives single output. How we can proceed to have multiple outputs, sir?
And gives
In chat box, they posted a question. ANFIS gives single output. How we can proceed to have multiple output?
so ANFIS is used for tuning the values only, for best optimized values only it will produce. How can we proceed to a multiple output?
Okay, sir. One more question from the participant side. What is the minimum value for bandwidth noise? I think
So I don't
half
know.
of the question only he typed. I think so.
Okay. What is the
Maybe noise filter like.
minimum value?
Okay, sir.
Okay.
So mention some techniques, simulation techniques used in gyro sensors.
Simulation techniques.
Simulation platforms. Simulation tools,
Simulation tools,
only MATLAB.
Other than MATLAB, I didn't do so. So in future, I will work at them.
So, one more question from participant side, sir. What extent is sensor fusion technology is used in field of
Okay,
biomedical?
Nowadays in biomedical instrumentation, many biosensors are there. For example, we are having a combination of temperature sensor, pressure sensor in the watch itself. Nowadays we are having some Google Watch. In Google Watch, they are using this kind of sensor fusion to analyze our body values like temperatures, pressures, like that. I think the another question, transfer function for most of sensors are not available in real-time scenario. How we can we find the transfer function?
Yes, sir.
So in control system, before talking to the transfer function, we will use the system identification toolbox. In system identification toolbox, we can collect the values of sensors. And if we provide those collected values from the sensors and provided the system identification toolbox means it will provide it will convert it as a transfer function. So if you use system identification toolbox means you can able to get the transfer function. Otherwise, by referring many old literatures or any literatures, you can get the transfer function. Otherwise, you can use non-linear transfer function means we are transforming those non-linear values into linear values. So transfer function means we are going with the linear system only.
Thank you, sir. Shall I conclude the session, sir?
Yes, madam.
On behalf of our PSR management, my heartfelt thanks to our beloved resource person, Dr.G.Prabhakar sir, Professor, PSP Engineering College, Karur. Despite of his busy schedule, he found time to share his knowledge in the field of sensor fusion in robotics, reliability and quality of sensors, and how sensor fusion is used in autonomous system and fusion architecture, details about fusion architectures and fusion technologies. And also, he shared his research ideas in the field of implementation of sensor fusion in robotics and used in physical system. Thank you, sir. Thank you for wonderful technical and valuable information. Thank you, sir.
Thank you, madam. Thank you. Thank you for the management and the HOD and coordinator of this activity. Thank you.
Thank you, sir. Dear participants, so we start the next session at 2:30 p.m. Thank you.
எக்காவது போயிட்டு இருக்கா லீவ் கொடுத்தாதான் அங்கே
டைப் பண்ண மாட்டேங்குது.